Hello, I'm Joseph Burchfield. I'm in a group together with Emily Carpenter, Andrew Miller, and Haley Robert. We all work together at TDOT, so we all have a strong background in transportation. This class has had a lot of new material that we're unfamiliar with, so we chose to go with a project looking at the hog waste problems in the flooded lagoons after Hurricane Florence. To give some introduction, uh, the way these systems work is that whenever the pigs do their business in the buildings in which they're housed, uh, the waste goes into the floor and is then washed down uh, through drain systems in the floors, which is gravity fed out into lagoons where anaerobic digestion then helps break it down and treat it so that it can be applied over land as a fertilizer. And whenever Hurricane Florence came through, overtopping and breaching of the embankment walls allowed much of the material to be picked up, carried out, and swept downstream, bringing about some widespread pollution with some really nasty material that's not easily recaptured or treated, and it's also quite dangerous. So we started looking just to learn about what these lagoons were and how they functioned, and we learned that there really wasn't a great amount of planning that always went into their construction, such as the surrounding topography, differences in elevation between the buildings and the lagoons, uh, making appropriate plans for possible future expansions. So we weren't even sure if they had many existing standards to work with or if they were enforced. But either way, even if they did, it sounded like they may have been insufficient and that we could perhaps suggest improvements. That was the main section that I worked on in the report, was to look for existing standards. We have those from North Carolina, and they're based on lagoons that from the bottom of the lagoon to the top of their embankments have an effective height of 35 feet. And the standards are mostly there in place for those where other buildings on the farm, as well as other adjacent properties and local roads and towns, would be at risk in the event of a breach. Uh, State issue permits must go out for any new construction, and they must apply with existing state and local laws and ordinances. And a permit is also required whenever the embankments are more than 15 feet tall and whenever the lagoons contain 10 acre feet or more of waste. They're supposed to try to avoid being in floodplains when possible, and they shall not be constructed in 100-year floodplains. Areas such as churches, playgrounds, schools, parks, as well as any residences, unless it's the residence of the farm owner or any tenants that they have living in a location that they own, are not supposed to be within 300 feet of a lagoon. New construction, however, has a minimum distance of 750 feet. Now, these standards are back from the 80s. If it's perennial water or wells or any area specified by the state or the local municipalities, then it's supposed to be 100 feet minimum. They also had some updates to these standards in August 1997, where any residency period is supposed to be a minimum of 1,500 feet away from the lagoons. Public facilities, again, the churches and schools and such, should be 2,500 feet away. Property lines and wells would be 500 feet at minimum, and whenever the effluent is recovered from the lagoons for use as fertilizer, the fertilizer is not supposed to be applied over land any closer than 75 feet from a property line. Whenever they are creating new lagoons, a big issue is always going to be odor control. And so any new ones that they are putting in, or if the lagoons have been emptied and they're being prepared to be put back into use, they're supposed to be pre-charged with approximately half of their total treatment volume with water so that the solid material that's introduced to it will have something to quickly settle into to help reduce odor. The inlet pipes that's coming from the pig houses are supposed to always drain below the liquid surface, and the outlet pipes that would be used for capturing for spraying should be at least 1.5 feet below the liquid surface level. They also want to use vegetation as a shield around the lagoons to help prevent wind from picking up odors and carrying it. Anytime that they are going to do any new construction, they're supposed to develop an emergency action plan in case something bad were to happen. These contain a list of state and local officials that they're supposed to contact when an event like a breaching event happens. They also are supposed to have the contact information of the local sheriff and a contractor that could make emergency repairs in the case of a breach. They also are supposed to try to contact the technical specialist who made the initial certifications for the lagoons, and if they're no longer available, then they're supposed to try to find someone else who would be capable of making that same certification. These emergency action plans are supposed to be posted on site for every lagoon, and whenever they are preparing to construct a new one, they're to excavate an observation trench at least 5 feet around the lagoon for any soil that has high permeability, so that they can monitor the leaching effect of the lagoon material as it's seeping out and into the surrounding environment. Any tiles that are within 15 feet of the toe of the cut slope of embankments are supposed to be removed. And for local property owners that are adjacent to the farm, even if they're across a road, they are supposed to be notified of the intended new construction of a lagoon anytime that one's going to go in. For the soil that it's going to be constructed on, they want one with low permeability, but they can also use liners to help reduce it. They're supposed to use the same standards for the embankments. If the soil type is SP, SW, GP, or GW, they must have a liner. They're usually going to use a clay liner with a conductivity of 1.25 times 10 to the minus 6 centimeters per second. And the lagoon bottom must be at least 2 feet above the seasonal high water table, though they can use pumps to draw it down further if that change in the water table is not going to harm any surrounding properties. Typically, pigs weigh about 135 pounds apiece, and they're expected to produce 1.37 gallons of waste every day, and so they use that to size their containment lagoons for the waste. They're also supposed to account for any excess water used for flushing the waste into the system. The treatment time is supposed to be a 60-day minimum, though it may need to be longer if it's necessary to treat it to the point that it can be safely used as fertilizer. Anytime that they're doing this, it's also going to build up a constant accumulation of sludge, and they must also have enough volume to anticipate this sludge and how much of it is going to collect in the bottom of the lagoon in between every pumping phase. They also must consider added depth due to regular precipitation rates, rain that would come from a 25-year, 24-hour storm, and they also need to create another factor that's pertinent to the local area for any extreme event that would even exceed the 25-year, 24-hour storm. The lagoon bottom is supposed to be level, and the embankment could have a cutout key, kind of like a large concrete root that'll help stabilize it, as well as create an impermeable surface to help further keep the material contained. The slopes are supposed to be uniform, and if they're having to do cut slopes or work on the bottom of the lagoon, they're supposed to excavate 6 inches deep and then highly compact it. The top elevation is to be a foot above the lagoon surface. That's the freeboard, and they're also supposed to add at least 5% extra to the height above that freeboard of the embankment tops to account for settling. If they're going to use it as a one-way road, it should be at least 16 feet wide, 26 feet wide if it's going to be a two-way road. And if the embankment is going to be at least 20 feet tall, then the top width, even if it's not used as a road, must be at least 10 feet wide. Up to 24 feet, it would be 12 feet wide at the top. Between 24 and 30 feet, 14 feet wide, and 15 feet wide if it's 30 to 35. And there were no standards given if the height was increased above 35 feet. They're supposed to be at 3-to-1 slopes. They could also be flattered, and layers are supposed to be compacted at every 9 inches. The inlets that brings the waste into the lagoon are supposed to be able to resist the degradation from corrosion and clogging and freezing. to help alleviate problems that would be caused by freezing. They're supposed to use a 6-inch diameter pipe, and it's supposed to have at least a slope of 1% downgrade. They can use a water-sealed trap and vent to keep gases from re-entering the buildings where the pigs are at. And the outlet pipes should also be far enough away from the embankment so that it will not cause erosion, as well as to be deep enough that it will not freeze. The outlet for the lagoon should be as far away from the inlet as possible. This allows solids to drop out of the system and collect as sludge in the bottom of the lagoons. And they're not meant to automatically discharge either. It is supposed to be controlled. If no pumping is used, then they're supposed to have a 6-inch overflow pipe leading to other lagoons or maybe a storage basin. It should be able to prevent overtopping even at the seasonal high time for the pig waste generation. And the overflow pipe is supposed to be at least 6 inches below the surface. If the maximum intended level is 3 feet or more above the natural ground line, provide a spillway. The crest for that spillway out of the lagoon is supposed to be in undisturbed soil, but if it's going to be built into the embankment, they need to have extra precautions built into the embankment to prevent erosion. And they also want to always keep it designed and have enough in place that it will be able to handle a 25-year, 24-hour storm without having overtopping. Any lagoon that has at least 1 million cubic feet of storage volume must have an emergency spillway. We've used these to come up with our different solutions. One solution is to basically to beef up the embankments to give greater freeboard and to make them less prone to failure so that they can handle a higher grade storm event. And another solution we've had was to consider having a system that's buried underground. That would be far more difficult to construct and to design. It would probably be economically unfeasible, but an extreme problem does perhaps require an extreme solution, and we go into more details of this in our report. We've also noted something that is going on in North Carolina. For years they've been carrying out a buyback program where they try to purchase any lagoons that are within the 100-year floodplains and dismantle them and empty them of their contents. Thank you.